Hi folks, we're here to talk a little bit about the science behind the TestDrop Pro. We have here two cups. Both of them are polypropylene. One has water from a water bar that has multiple filters in it. The other has the same water from which I took a drink, and so it is contaminated with my saliva. Again, it doesn't mean it's dangerous, but it is contaminated. As we mentioned in our instructions, you have to swirl up the cup a little bit, and I'll explain why in a second. Take the device, push one of the three buttons, come in, touch the cup, let go, you see a blue light. That means we did not detect contaminants. We take the same one that has the saliva, okay, swirl it up a little bit, come in, touch the cup, let go, and now you can see the red light. Now, what we have is as follows, that the leach tote technology is based on the interaction between the water and its container. Water, when it interacts with the container, can transfer charge to the container, and doing so that generates electric fields. Our device, as is moving through space, measures these electric fields, which on the clean samples becomes more and more negative. We've trained the device to look for a certain profile of fields, and if it finds that, it gives a blue light. Anything less than that or anything different than that, it gives a red light. Now this means a couple of things. Firstly, why do we use plastic, and why do we tell people not to use glass or other materials? There are two basic reasons for this. One is that the biggest fields, the biggest results we can get, which allows for the greatest discrimination and sensitivity, comes with plastic. Glass, metal, wood, they all give the similar phenomena, but they're much, much weaker, and it's much harder for us to distinguish between clean and not clean. That's number one. Number two, when you do this kind of mixing, we're on the assumption that for a cup like this, it's never touched anything. It came out of a sleeve. It's not only clean, it's actually sterile. When you have a glass, glass, where you have some type of cup from wood or something like that, it's been cleaned, it's been used. There's something left in the cup which might contribute to the signal. So if you get a red light, you don't know if that's because the water is really dirty, or because actually there was just some soap left over from the last time I cleaned it and I didn't really rinse it out well enough. So again, we use plastic. Now there's another very, very important point. Most people, most of our customers, they're testing their water. It can be from a faucet, it might be from a well, it could be from a bottle of water which they have, they want to find out if it's good water. Some people like to put on the lab coat and they want to be scientists, which is fantastic. And so they want to mix things and say, okay, if I mix X into water, what does it do? So what happens is when I swirl this up and I charge my cup is charged. And now if I add something, the charge is still on the cup. So we've had a couple of people who've written to us and said, look, I had clean water, I added something, and after I added it, it still came out as blue. Why is that? Well, because the cup is charged. And so even though you added something, the charge that you left on the cup is still there. So if you want to do any mixing, that's fantastic. It's a great way to learn more and more about the device and the impact of different materials in water. But all the mixing has to be done before you put it into the testing cup. It should preferably be done in a clean glass container. You don't want to put it into plastic, because what you do in plastic, where you mix, is the same thing that happens over here and can affect the charges you would see on your testing cup. And you want to make sure that it's clean glass. Okay, so if you want to mix some type of chemical into water, mix it before you put it into the testing cup. Okay, that way you're going to get the most honest results with respect to what is the effect of the presence of that material in the water itself. Okay, a couple other points. Because the actual measurement is the field associated with the cup, you have to leave part of the cup available for measurement. We generally say fill the cup just over half. That's excellent advice. Some people have filled it way up towards the top, and what they do is they don't leave enough of the exposed plastic to actually get a field measurement. So you don't want to fill the cup up too much. It's also best not to reuse cups at all, because again, this cup now has charge. Even if I throw something out and put something else in, there's still the residual from this test. The same over here. This cup is red. It'll never be blue again. Okay? So, reusing this cup is not going to help, but even if I have a perfectly clean sample, putting into a cup that's already been used is going to lead to a result probably identical to what the previous sample was. So please use new cups. Take them out of the sleeve and test them. Don't leave them out so you can have dust or other things fall into them before you use them. And again, you want to come straight in above the water line and then make a measurement. You can transfer data to your cell phone, look at the graphs, etc. But again, these are very, very important points just to make sure that you get optimal usage of your TestDrop Pro.